Sikhote Alin meteorite. A 1956 documentary directed by Israel Cesarevich Gradov. The huge meteorite fell in the area between Khabarovsk and Vladivostok, in Sikhote Alin Mountains on February 12, 1947 at 10:38 a.m. local time, 46 degrees 7 in, 134 degrees 40 E. The swift meteor flight and its smoky light could be seen for hundreds of miles. The local artist, Medvedev, as an eyewitness, portrayed this rare natural phenomenon. The fall site was found by pilots flying above the forest. They noticed clearly distinguished in the snow cone pits among the fallen trees. Soon geologists appeared in the snow-covered taiga, Ermolyuk, Tatarinov, Anisimowsky and Shipulin. For 3 days they made off-road way in deep snow looking for craters. Here they are, the traces of a meteorite fall. The geologists examined the damages and counted more than 30 cone craters. They mapped them and began to clean up one of the craters. Look, this is a spall of an iron meteorite. The prospecting results has been reported to the Academy of Sciences of the USSR. The Academy organized an expedition to the fall area, headed by academician Fesenkov. Scientists had left for Vladivostok and routed through Iman to Novopoltavka, the last settlement on the way of the expedition. Here they joined by a group, whose members had visited local villages and recorded the testimony of hundreds witnesses of the meteorite falling. Only 12 miles separated the expedition from the target, but the path was very hard through the Ushuri taiga. The road was blocked by wind-fallen trees and vernal flooded streams. Suddenly the taiga had thinned. Look, the crater. Another. The third. The whole crater field. The camp was set up in a near birch grove. Survey of the craters had begun. From the pile of stones meteorite fragments were dug. Samples were flattened with sharp and jagged edges. These scars are signs of the impact. Pressure at that moment reached 10,000 atmospheres and many splinters were strongly bent. A magnet found tiny meteoritic particles in the soil. Such iron dust saturates the whole field. To the north from craters in the wild taiga, the whole meteorites have been found which have not broken up at falling. Such meteorites is called by scientists, the individuals. These meteorites differ from splinters the melted off and original pitted surface, as the evidence of atmospheric interaction. On many samples the fused metallic splashes have remained, or the hardened jets or droplets. Drops were blown off from falling meteorites and settled in the ground. They have been found out at soil research. Slightly melted off fresh breaks were exposed on the surfaces of some individuals. It is the evidence that all fallen meteoritic samples made the uniform body which had broken up in the terrestrial atmosphere. The big fragments have formed craters at falling, and had broken into thousands splinters. The crater's position was measured by the theodolitic survey. The map was made on its base. The trees had been damaged around the craters. Study of whole falling conditions and the testimony of eyewitnesses allowed to define a meteorite way in the atmosphere and then to calculate its orbit in interplanetary space. It is known that there are numerous minor planets, asteroids, between orbits of Mars and Jupiter. Some asteroids' paths crossed the orbit of the Earth. Academician Fesenkov calculated the Sikhote Alin meteorite orbit, and found that it was one of small asteroids, moving with a speed of 40 km per second. The meteor has caught up with the Earth, blew through atmosphere, and broken up to fragments due to huge air resistance. The expedition head, Academician Fesenkov, is speaking. The value of Sikhote Alin falling is concluded in that it was the first time in mankind history the crater field formation in real time, as a result of collision of a small asteroid with the Earth. This falling obviously shows the relationship of meteorites and asteroids and allows estimating a role of meteorites in solar system. The second expedition of Academy of Sciences was directed to a taiga for advanced meteorite collecting. The rapid spring flood forced the scientists to change the way of movement. They went against a rapid Baitsuk River current using poles. Then floated on the river Kanak and had landed in 12 kilometers from the crater's field. The taiga had met researchers with dense thickets of creeping plants, prickly bushes. The expedition was headed by the magnetologist Sergei Fantin. The difficult way has left behind, and the group approached the camp in a birchwood. In a taiga again had begun to knock axes. Glades were laid. There was a preparation for aerial survey. The recognition signs were hung on high trees as the reference marks for pilots. All area of meteorite falling was photographed. These are the aerial photos. They were used to make an exact map. On the map the dark circles indicate places of falling of meteorites. The area of iron-strewn field is spread out on the area about 2 square kilometers. The strewn ellipse extends from the north to the south, in a meteorite movement direction. Simultaneously, the geological study of craters field were conducted. The rock layering and its characteristics was studied. Features of meteoric cones were sketched. As the meteorite was iron, the magnetic method was used during searching. The magnetic survey network was set up. Then the terrestrial magnetic field intensity was measured by a magnetometer in each point. The device marked the raised intensity of the soil, where there were meteorites. The made graphs determined the fields of splinters or places of large meteorites. Now it is possible to start excavation. The large meteorite is found. Excavations were made by combat engineers. Meteorites pierced a soft ground on depth to 8 meters. This visually small meteorite weighs 250 kg. Raining turned many cones into ponds. It is hard to dig out such cone. After water pumping out, there was damp, swollen clay in it. According to magnetic surveying, it should be a large meteorite here. And it is true. The 700 kg meteorite was taken from this pit. Works in a taiga were carried out with brakes during 4 years. In the winter of 1950 had been discovered the biggest crater, with diameter of 28 meters. Here the meteorite had fallen to rocky stones and was shattered into set of splinters. In the same winter, the largest individual meteorite had been found. It weighed 1745 kg. For all time of works, scientists revealed 93 cones, collected 355 individual meteorites, and about 7,000 fragments, in gross weight of 23 tons. But not all cones were unsealed. It has been decided to keep the third of the most typical, having protected by tents from a bad weather. Expeditional works had been finished. The strewn field was declared as the State National Park. The comprehensive study of the Sikhote Alin meteorite was continued in academies of sciences at Moscow. Meteorites are unique extraterrestrial bodies, which directly could be studied in laboratories. The meteoritic substance were undergone to the chemical analysis. Analyses of many samples measured exact composition of a meteorite. The significant abundance of nickel distinguishes meteoritic iron from the terrestrial. The spectral analyses of the meteorite have found out the admixture of 26 elements. Spectrum lines have shown that the meteorite contains copper, germanium, chrome, gold, platinum, and other elements known on the Earth. The uniform distribution of admixtures shows that the Sikhote Alin meteorite made a part of a large extraterrestrial body. The study of the internal structure of a meteorite also reveals conditions of its formation. The surface of a meteorite etched by acid demonstrates its structure. It is combined from separately large crystals of alloys of iron with nickel. Such structure pointed to slow cooling of an alloy during millions years. Layered inclusions of various minerals were conducive to meteorite disintegration in air. Mechanical tests of samples have shown that destruction occurs along these layers. The thin parallel lines crossing each crystal are clearly defined under a microscope. In splinters, these straight lines are bent as the result of meteorite blow in the ground. Various samples of the Sikhote Alin rain from the tiny to large iron blocks have filled up the richest collection of Academy of Sciences. It represents many remarkable meteorites. Pallas iron is a huge iron sponge with mineral grains of olivine. Boguslavka meteorite is the single Fe crystal which has broken up at falling. The carbon meteorites are remarkable because a water has been found in their composition. The stone meteorite Nikolsky represents a friable aggregation of many crystal balls. All these, would seem various meteorites, have got a common origin, and are fragments of one or several planets. Meteorites are close to deep terrestrial rocks. Their study is important for knowledge of inaccessible to us Earth interiors. Research of meteoritic substance reveals secret of planets' formation, and emphasizes unity of a matter of the world surrounding us. The richest material for science has given the Sikhote Alin meteorite. The end.